Assalamu alaikum and welcome back to my YouTube channel. Students, today we are going to discuss the MCQ of Unit 4, that is work and energy. So the first MCQ is, you push a heavy crate down a ramp at constant velocity. Only 4 forces act on the crate. Which force does the greatest magnitude of work on the crate? Student, as we have discussed in this chapter, whenever we will push the crate, it means we are giving the frictional force, normal force, force of gravity, and the external force that we are applying to push the crate. So the question is, which force will be the greatest in magnitude? And definitely whenever we will push the crate, it means there will be friction between crate and the ground. So the greatest force in magnitude will be a force of friction. Force of friction is when two bodies will be in contact with each other, then they must have frictional force there. The second MCQ is, the force constant of the wire is K and that of another wire is 3K. When both the wires are stretched through same distance, if work done are W1 and W2, then means which work will be greater, and up to some how much extent they will be greater. Then we will find the relation as W1 equals to W2. So work 1 is half kx square, and they are giving us the condition that if W2 will be 3 into half kx square, definitely then work W1 will be equals to 3 into W2. So the option C is the correct option. The third one MCQ is, escape velocity on the surface of Earth is 11.2 km per second, and we have proved it. If the mass of Earth increased to twice its value and the radius of Earth become half, the escape velocity is. So first of all, we should know about the formula for escape velocity. Formula for escape velocity is V escape equals to under the root 2g me divided by re, where g is gravitational constant, me is mass of Earth, and re is radius of Earth. And what condition they are giving us is, if the mass of Earth increases to twice, means that this mass of Earth is twice according to the given condition. So we will use g into 2me, and the further conditions is radius of Earth become half of escape velocity. So we will use re by 2, means it will become half. Then what will be the value of escape velocity? So V escape will be equals to under the root 2 is on third place and it will be on first place, then it will become 2g into or we can say it 4 me divided by re, or we can write it as V escape is equal to, we will separate this 4 and into 2g me divided by re. So under root 4 is equals to 2. Students, I forget to turn on the camera. Then I was telling you 2 into GME divided by RE, and it has constant value of 11.2 km per second. So whenever we will multiply this value with 2, it will be 22.4. So V escape will be 22.4 whenever we will increase the mass 2 times and we will halve the radius. Thank you. Then next MCQ is an example of non-conservative force. Of course, frictional force is non-conservative. Conservative forces are those forces having work done in a closed path will be equals to 0. The fifth MCQ is, when the speed of your car is doubled, by what factor does the kinetic energy increases? So kinetic energy increases with the factor of 4, and like we will use a relation of kinetic energy with speed, as kinetic energy is equal to half mv square, and here the relation is given this one. So kinetic energy will increase 4 times. 1 horsepower is given by 746 watt. It is the British unit for measuring the power. Work is said to be negative when force and displacement are anti-parallel. So the next MCQ is, work is said to be negative when force and displacement are, of course, anti-parallel, because the formula for work is W is equal to F dot D, or FD cos of theta. So cos of theta, if it will be parallel, then theta will be equals to 0 and work will be FD. Cos of 0 will be equals to 1, and if they are anti-parallel, means having opposite direction, then they will make the angle of 180, and cos of 180 will be equals to -1, so the relation will be minus FD. So work will be negative in case of 180-degree angle. Okay students, the 8th MCQ is two body of masses m1 and m2 are having equal momentum. Their kinetic energy is E1 and E2 in the ratio of. So first of all we will observe the relation of kinetic energy with masses. So the formula of kinetic energy in term of momentum is p square divided by 2m, and I will derive this relation for you people. And means that kinetic energy has inverse relation with mass. If kinetic energy, the ratio of kinetic energy will be like m2 divided by m1, because they are inversely related with each other. So we are going with option C. Okay student, the atmosphere is held to the earth by gravity. And 10th one MCQ is if momentum is increased by 20%, then kinetic energy increased by kinetic energy increased with a factor of 20 plus 20 into 2 multiplied by 2, it will be 40 plus 4, 44%. If question can be like if momentum decrease, then we will use here the negative sign. Okay, the next one is if the kinetic energy of body become 4 times of initial value, then new momentum will be. So first of all we will see the relation of kinetic energy with momentum having mass. So if we rewrite it as p square is equal to 2m into kinetic energy, or we can write it as energy. We will remove the square by under root. It will be p is equal to under the root 2me. Now we are observing the conditions. If kinetic energy of a body become 4 times, if kinetic energy will become 4 times, then we will use the 2m will be as it is and energy is 4 times. Then it will be p is equal to 4 under root 4 is equal to 2, and then into 2me, or we can write p is equal to 2pe, means momentum will increase twice its initial value. So we are going with option A. The 12th MCQ is two bodies with kinetic energy in the ratio of 4:1 are moving with equal linear momentum. The ratio of their masses, as I told you previously, kinetic energy with masses, they have inverse relation. If momentum is increasing 4:1, then definitely masses will be 1:4. So we are going with option D. Option D is the right option. The 13 MCQ is a body of mass 5 kg is moving with momentum of 10 kg per meter per second. This will be the initial momentum. A force of 0.2 Newton act on it in the direction of motion of body for 10 seconds. The increase in its kinetic energy. First we will find the final momentum. Initial momentum is given, then we will use in the relation, and then we will find the kinetic energy. Now for this MCQs, first we will find the initial kinetic energy, then final kinetic energy, then change in kinetic energy. So initial kinetic energy is kinetic energy initial is equal to initial momentum divided by 2m. So it will be kinetic energy equals to initial momentum is given 10 kg and mass is 5 kg. So it will be 10 divided by p square. So it will be 10 square divided 2 multiplied by 5, and initial kinetic energy will be equals to 10 square will be 100 and 2 5s are 10. So it will be 10 10s are 100. So we are left with initial kinetic energy is 10 joule. Now we will find the final kinetic energy. Final kinetic energy formula is final momentum का square divided by 2m. So first of all we will find this final momentum. The formula for finding final momentum will be as the relation of force is equal to change in momentum divided by per unit time. So now we have to find this change in momentum. It will be change in momentum equals to force multiplied by time. So force is given. How much force is given? force of 0.2 Newton. So 0.2 multiply, how much time is given? Time is 10 second. 10 second. It will be change when we will multiply 0.2 with 10, we will get its value, that is 2. Now we will find the change in momentum. The initial momentum is given 10 and this change in momentum is final. So change in momentum is equal to 2. So how we will find the final momentum? Delta P is equal to PF minus PI. We have to find this PF. PI will be PF equals to delta P plus PI. So it will be PF is equal to delta P is 2 plus initial momentum is given as 10. So final momentum B equals to 12. Now we will find the final kinetic energy. Final kinetic energy will be kinetic energy final is equal to 12 ka square divided by 2, mass is given as 5. So final kinetic energy will be equals to 12 square is equal to 144 divided by 2 5s are 10. So final kinetic energy, when we will calculate the value, it will be equals to 14.4. Now this final kinetic energy is given. We will find the change in kinetic energy. Change in kinetic energy will be final kinetic energy minus kinetic energy initial. So kinetic energy final is 14.4. We will minus this with 10 joule. It will be change in kinetic energy, that is equals to 4.4 joule. So our answer 4.4 joule is the right option. So option D is the right option. 14 is if force and displacement of particle in the direction of force are doubled, work would be. So formula for work is very simple. W is equal to F dot D. If force is doubled and displacement is doubled, so it will be 4 times F dot D, or we can say work will increase 4 times. So all these MCQs with solution are solved, and if you want such conceptual answers, do subscribe this channel, like the videos and share more and more. Allah Hafiz.